Okay, now, standing waves. Here's the idea. The ends where the displacement of the wave is always zero. By the way, it doesn't always have to be in the ends. But locations where the displacement is always zero are called nodes. Nodes. Spots where where you're going to reach the amplitude, displacement can be a maximum, are called antinodes. Antinodes. Okay. Now, how this is actually formed? Think, if you will, for me, interference. Okay. I'm going to have a wall here, if you will, and a string attached to the wall. I send a large pulse wave down the string. Okay? Down the string. Let's say this is at t equals 0. Never mind my string is at an angle. T equals 0. What happens whenever it hits the wall? It's reflected back, and what's it going to look like? It's going to be upside down. What's that phase we talked about here? Pi, right? Pi out of phase, inverted, pi out of phase, 180 degrees out of phase with what we sent. And so at, just picking random times here, right? At t equals 1 now, I've got the wall, the string, and the wave inverted. Now, at the exact same moment, this is why it only happens at very specific frequencies, okay? At that exact same moment, as it's getting reflected back, I send down the other way an inverted wave. What happens with those two waves? They add. That is constructive interference, right? Two waves, both the same direction, means the amplitude is going to become twice as large, right? Giving me total, these two added, very big. Doesn't matter.
I mean, you said there was no direction.
Specifically in the amplitude part. Down, if you will. All right, down, if you will. They're going opposite directions, though, and that's a critical factor for standing waves. Right? It's constructive interference occurring whenever the energy is allowed to, or the wave is allowed to reflect off a wall, okay, come back at you, and then constructively interfere with another wave you're sending down. So now, if you will, imagine for me, the red comes back, and let's just say it dies out. T equals 2. What happens to the small green wave? Now, red came back at us. The red was moving this way. The green was moving the other way. So the green now hits the wall. What happens? It's reflected, right? It's reflected. And where? Up on the amplitude or down? You know, if I call this positive and that negative. Positive or negative amplitude? Positive displacement, giving me the positive amplitude. At that exact same time, if you're thinking about what's happening with my hand, right? Hold on a second. At the exact same time that the wave reflects back positive, my hand is moving back up. Okay? So I end up getting, whenever the reflected wave hits and comes back, my hand is mimicking and doing the exact same thing. In other words, I'm sending a wave down the line that has the exact same, if you will, opposite direction, right? One's going to your right, the other to your left, right? Because one's being reflected. But it has the exact same look, if you will, okay? Coming out of my hand as the one getting reflected. All right, so here, at this time, I'm taking the string. Yeah, the reflected wave is coming back. It's up. I'm going to take the slinky here, and I'm going to go up also. Meaning I'm sending, green one coming back at me, I'm sending a wave pulse that's also up. Constructive interference occurs. I get a very large amplitude for it. Add those two amplitudes. Okay, add those two amplitudes. That's the idea of a standing wave. So a standing wave does not mean it's frozen in time, right? It means that for the fundamental, it gives the appearance that it is oscillating. Sometimes it's all the way up, right? Sometimes it's a little bit lower. Sometimes it's at 0, and then goes back negative and down to the amplitude. The displacement of a standing wave is always changing. The displacement of a standing wave is always changing, and only at very specific times is it at the positive or negative amplitudes. Okay? Now, let's talk about energy. Waves transfer energy, correct? That's the purpose of the wave. Waves, what do they not move? The medium, right? The air particles aren't flying out of my mouth with the sound waves into your ears. That'd be gross. Right? Remember we talked about that. Ocean waves don't transport the water particles. That's the tides. That's a different idea. And then more of a figurative thing, right? With a wave around a baseball stadium, the people aren't what's getting up and running, right? The medium just goes up and down. But what is being transferred? Energy, right? In a standing wave, is there any net energy transfer? Keyword being net here, energy transfer. No. There is no net energy transfer. There's no net energy transfer. If you will, if you want to look at this in a more microscopic view, right? The wave, right? The energy goes down the string, right? And then gets reflected back to the starting source, right? Net energy transfer, nada. Nothing. Okay? If you stop the entire process, the energy is going to hit the wall and come and reflect back to where it was. So, still with you, no net. No net. Whenever it's reflected back at you, no net transfer. Now, this right here, this idea, let me slide. This idea for, let's deal with closed on both ends. Both ends, closed on both ends. This is the first harmonic. First harmonic, also known as the fundamental. Band folks, by the way, I'm talking about harmonics. Things should be going off in your head. Okay? Things should be going off in your head. And where you're thinking down the line of, hey, you know, whenever I'm playing the trumpet, I have, you know, if you will, harmonics where with all valves open, not changing the length of the pipe, right? I'm able to hit very specific notes in jumps. You're creating standing air columns, by the way, standing waves inside that instrument. This is the fundamental. Second one looks like this. So wave goes down, right? Wave goes down, and then is reflected back. Change color just for effect. Creating a standing wave that looks like that. 3 nodes, 2 antinodes. That would be your second fundamental. Not second fundamental, excuse me, your second harmonic. Second harmonic. The fundamental only refers to the first harmonic. Okay, likewise, third, dot, 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 dot. As always, please excuse my terrible drawings. Right? And have 3 bubbles. That'd be your third harmonic. And the higher we get into harmonics, as the band people can attest, the harder it is to get to work. Right? The harder it is to get to work. I mean, think about it, band folks. How hard is it, especially brass instrument guys, right? You start trying to hit those higher harmonics. We're talking, you leave all valves open, trumpet player, right? And you go up and up and up and up and up and up and up, and yeah, eventually you ain't going up no more, right? You're kind of done, and you're not. It's hot. It's a lot harder to hit those higher harmonics. Let's see if we can't get a second harmonic going on here. A little bit booster on the tension. Nope. Come on. Maybe. Almost. Woohoo! A second harmonic. Right? Only at very specific frequencies. I had to find the frequency. And if I wasn't there at the frequency, it wasn't going to work. I hit a third harmonic once, but I'm not going to waste your time trying to do that. So, yeah. Oh no. Oh no. Ah, okay. Save. Now, Closed on both ends. This is what your harmonic's going to look like. And that's when, like with a string, guitar string would be a great example of this, right? You actually have grab physically are holding on to both ends, not allowing one end to move. Now, pipes can work differently, right? Pipes can be open on one or both ends. So let's deal with open on one end pipes, okay? By the way, you need these pictures. If you haven't been drawing these pictures, please do. Please do. You need these pictures. That means you can't pack up, can't you? Open on both ends. Your fundamental. That's your first harmonic. Looks like this. Two antinodes on the end, one node. Two antinodes. Open on, did I say one end? I just did open on both ends. That's the easiest fix. Open on both ends. Two antinodes. Okay? Two antinodes. And if you're open on both ends, everything always has to end in antinodes, right? You always have to end with an antinode. That'll be your next one. Now you have, instead of one node, two nodes, right? One node, now you got two nodes, right? And then you can keep going from there. I think your imagination can get where you need to go. Okay? Now, do I need to pause? We're good. Now, closed on one end, open on one, closed on one. Open one end now. That's a little bit different. It's a little bit off, right? I've got to have a node here and an antinode up there. So your fundamental looks like that. By the way, all the others, the fundamental is half a wavelength. We're going to get to that in a little bit. This is a fourth of a wavelength. That's going to be critical. Okay? This is a fourth of the wavelength. Now, first, our fundamental. Now, whenever we're trying to make the next one, once again, I have to end on an antinode and start with the node. Okay? I end up having to do this all the way down, up and around. That is not the second harmonic. Closed on one end, open on the other. You can only get odd harmonics. Because check this out. If this is a fourth of a wavelength, I said, how much of a wavelength is this? 3/4 is right. There's half of a wavelength, right? And then another little fourth tacked on. This is 3/4 lambda. We're going to continue with this tomorrow. This is good. That's the third. Open on one end, you can only get odd. You only get odd harmonics. Only odds. There. Only odds. Okay. Now those pictures are going to be, and being able to draw those pictures, are going to be your lifelong. You're going to need to be very, very good with them. You're going to need to be very, very good with them. Okay? Tomorrow, half of me those two outlines, half of me that A.1 homework, we'll go over that. Then also, we're going to finish up A.2. I expect A.2 homework tomorrow. Guess what's going to be due the next day? A.3 outline, that A.2 homework. See y'all later.